Okay, everyone, good evening. We are welcome to this class. We are going to jump in quickly to the lectures and then do some demos as well. So today looking at we'll be looking at big data, cloud technology. All of these are part of data analytics, and we would also be doing some demo on accessing data from the cloud. So it's going to be an interesting time today. So um, just check out my messages in the chat box and follow the class. Okay, so cool. So I'm going to turn on the full screen mode now so it can be clearer to us all. These are our objectives for today. Like I mentioned, this class is for everybody to have good knowledge of data analytics in their various domains and also have a good grasp of some basic technical background. So as we move on, listen attentively to all that I have to say about the theoretical part and then try as much as possible to follow through as well with the demo sessions, right? And you sure learn a few things. Okay, so cool. So remember we talked that big data is very important in the world of data analytics. And now looking at big data, the word big is relative, right? And bigness in the sense of things depends on whoever is perceiving it. So what is big data to company A might not be big data to company B. And then for analytics as well, depending on their wealth of experience, right? The type of data that they've encountered, they might, perceive some form of data as big and some as not being big, right? But big data to data that is large to someone who is seeing or experiencing such data for the very first time could become vague or look chaotic, or you could be lost in a big data. Let's say what you have been faced with before now is just a few rows of data in Excel, and then you are faced with hundreds of thousands of rows of data. That could come to you like a shock, right? And that's not even big data to some people. You can imagine how much big data the IT giant companies like the Google, the Facebook, the Instagram, you can imagine how big their data, is actually big, right? So we just want to help you with tips to facing big data, right? So we're going to jump in quickly to understand big data better and understand tips in facing big data. So for you to work with big data, you need to actually start exploring the data in small chunks, right? So, and this helps you to understand the data. And this is the essence of your explorative analysis, your descriptive analysis, and Excel, helps you a lot to achieve this. So in many cases, when we have to work with big data, we could just pick a chunk of that big data randomly, right? And then explore and see the various observations from that big data. So that's an important step to working with big data. So irrespective of the kind of data you are faced with, I think you should just pick a chunk and then observe. And remember what we discussed about data subjects and data features or characteristics. So these are important things you should know and understand in perceiving your data. So observe the characteristics, observe what are the subjects, and then the subjects will also help you understand the kind of innovative ideas you should derive from that data. So it's important you take a chunk of that data and observe it. Right, next is that you should interact with domain experts. Remember, we said that domain experts understand their data best. And in this case, if you are the domain expert, then looking at the data, you can tell the knowledge within various subjects and characteristics in your data. And you might even want to do some more checks or more research on the importance of those various characteristics in your data, right? Then also remember we talked about seasonality in data. Big data does not usually happen at a goal or at a point in time. Big data is most times accumulated data, and accumulated data is data over a span of time. So in most cases, you would find time series within your big data. You find seasonality within your big data. You find those kind of changes within your big data. So understand the concept of time series and understand how to best apply it with your big data. If you're not clear on these things I'm talking about, it's likely you missed the first lecture, and the video will be available for you to go refresh on all that we discussed in the first lecture, right? So the big data, I remember I said data is usually stored in databases, right? And then these databases they are available as softwares, and you should also get familiar with those databases. One of those databases that is for very, very, very large span of data is Hadoop. So if you're thinking of becoming a big data engineer, then you must be very familiar, or you must go learn Hadoop and know how to use Hadoop very well, right? And because Hadoop is very needed in very, very large data warehouses like IT giants I mentioned, but also in common use for most enterprises is SQL-based databases. I would say SQL-based databases because there are quite different ones of them. So it could be Oracle that also uses SQL. It could be Microsoft SQL. It could be MySQL, right? So the general language across all these databases is the language of SQL. And remember, we are going to be doing SQL in this course. So for anyone within the data analytics space, you are expected to be very familiar with SQL, right? So SQL as a data scientist is important. As a data analyst or a data analytics expert or big data engineer, SQL is the common language for you to assess and interpret and perform, functions on your data, right? So you should get familiar with those databases and how to interact with them using SQL. Then also, you should be deliberate and granular with dealing with big data, right? You should understand the deep, you should apply those principles of statistics in dealing with big data. Those principles of statistics that we discussed yesterday, the concept of statistics, they are not just theoretical, they have very good basis for working with big data, right? The concept of collinearity, the concept of correlation, understanding the significance of the correlation within your variables, all of these are important with dealing with big data. So it's important to understand these steps, understand this concept, and know how to apply them. You don't just jump into creating models on your data without having applied these principles. In most cases, when people do that, they come up with models that are not very insightful, or that are not very accurate, right? So it's important to know how to apply this in your big data, especially if you're working with real data and you're working for organizations that need clear insights from your data. then you should be solution oriented while working with data, big data, or any form of data. I'm saying big data because in the world of analytics, right, people are faced with different chunks of big data, and big data is relative, but any volume of data that is considerably large enough for you to make insight from is good enough for data analytics, right? So I'm talking to people who are keen on, making insights from data. So in making insights from data, those insights would likely be used by some end users, be it decision makers in company, be it um, um, company executives or political domain that need to get insights from the data information you are giving them. So in this case, you also need to be solution oriented. In being solution oriented, you might want to ask or know the kind of questions they want to answer from their data, right? So in understanding this, you might need to interact with the domain experts as well, or you could be doing a research, you could be into a research, and of course you'd have some research questions, and this must inform the way you are beginning to, explore your data, right? So these are various tips that are important to know for anyone who is particular about doing data analytics in the real world of things. So yeah, so for many reasons, sometimes you might have data that appears not to be big enough. You might have a chunk data, and that's all you have, and then you also want to make some insights from that data, right? So there are also some statistical ways of working with such data, and in doing so, because we believe that there is pattern or seasonality in large data, we also apply that kind of principle to small or relatively small data. The word small and big, they are relative. So I might want to just make my data become more. So in such case, I can consider the concept of data recursiveness and ensuring that this is in line with seasonality. It's not just a loop that is going forever, but understanding first the pattern in that data and applying that using some computer algorithms to create more of that data. Then you can also, this principle is well founded in computing using the concept of fractals. It's also well founded in statistics using the concept of trends and seasonality. So these are the ways you can improve on the amount of data that you have. Then you should also check the correlation in your data variables and ensure that the outcome is, predicting what is interpretable, right? So when regenerating your data must be connected, it must not be disjointed. So these founding principles of statistics and computing come to play when interacting or understanding your big data. So now, remember we said that data is accumulated over a period of time, and data is accumulated in databases that could be online or in the cloud. Cloud is just a remote location. We are going to look into details of cloud now, or could be accumulated in databases on server, on computers that are having higher capacities, which we call servers, and are sitting in some physical locations in offices or in data centers and things like that. So now I want to understand data in the cloud and in relation with cloud technology. So what really is cloud technology? You sometimes hear the word cloud, cloud, cloud. Cloud is synonymous to remote, right? Remote being that it's not within your confine, it could be in a different location at a different place, but you are able to interact seamlessly and virtually with the data as though it were right on your computer. So cloud computing is an on-demand availability for computer systems, data storage, and computing power. So data analytics companies most times use cloud. Even organizations everywhere most times use cloud. And the advent of internet and the challenges of our world today has made cloud computing very prominent and very popular. So for you who would be working with data that is not generated by you or from the field, and you are assessing some form of, or you are assessing some form of secondary data, you might need to understand how to use cloud, right? So for instance, the data that is generated from you through your mobile, right, is stored in the cloud. So your Facebook data is in Google Cloud DB somewhere, your Instagram data, your Twitter data, it's somewhere in the cloud. So all of these companies, have these databases that accumulate data from their different subjects. It could also be data from sensors. They are as well accumulating somewhere in the cloud, right? So why do companies use cloud? Cloud has a lot of benefits, and it has benefits on cost. That's even about the most important benefit for cloud usage, right? It's cheaper for startups and for big giants, to accumulate their data in the cloud. Cloud business is not used for data alone. We see some other different types of cloud, but for data analytics sake, we're looking at cloud in relation with data storage. So it's very good for cost. It's also very good for global scale. Remember, we said that data keeps on accumulating, and imagine your data storage as like something like your USB drive. So your USB drive is containing a database software that is accumulating data. So your USB drive could be limited in capacity to, let's say, 2 gig. So as the data storage on it continues to accumulate and extends beyond 2 gig, your USB storage would no longer be able to accept the data. It will tell you USB storage is full. So for you to increase the capacity, you need to drop that USB storage and buy a new one, right? So that's for physical usage of computing resources. However, for cloud usage of computing resources, all that is needed to do is to request for more storage space. So instead of you storing your data, imagine you are collecting field data as a researcher, right? So instead of you storing your data on your computer or on some hard disk software or USB storage, like I just mentioned, you could sign up for a cloud space. And you hear people talk about AWS cloud. You hear people talking about cloud storage and all of that. It's accessible to everyone. You could sign up online for a cloud space, and then as you're getting your data, you are storing it right into that cloud space, right? So these are examples of ways that individuals, startups, organizations make use of cloud technology. So it's available for global scale for any and everyone. And the cloud business is quite a simple business. It's just, concentrated resources on hardware and then making it available to everyone. So these cloud companies, what they do is they have very, very large-scaled computer hardwares, network hardware, servers in large racks and all that. And then they have some connectivity to those hardware through the internet for anyone who is signed up to use their cloud, um, to use their cloud, to use their devices. So because they are providing, this um, facility on a large scale, is easier for everyone, for them to scale their customers on it and for them to manage their customer on it. It's just like a principle of, economics on, large scale advantage and all that. So you have some local cloud businesses as well. Like in Nigeria, I know of Main One that is servicing most of all the banks for their cloud storage. And in the world generally, for everyone use, you can use the AWS cloud, which is about the most popular. And you have the Google Cloud as well, and you also have the Microsoft Cloud, known as Microsoft Azure. So that's about on global scale. Then you have other beautiful advantages of using cloud in performance, in speed, in productivity. You can just think of these advantages based on all that I've mentioned earlier. And also in disaster recovery, you don't need to worry of your data getting lost, right? Because it's securely stored and there are protection rules for these various data that is stored in the cloud. So just in case, if you have a need for cloud and you don't have a cloud space yet, you could think of getting on the cloud. It's just, you signing up for cloud usage, right? So there's also types of cloud computing. You have the public, you have the private, and then you have the hybrid. The most popular one is the public, which is cloud facilities in remote location available for public use. So anybody can sign up, right? And it's easy to sign up. You just get on their internet page, web page, AWS, or whichever one that is your choice, and sign up for cloud. And then you have cloud available for you. Even your Google Drive, most people use Google Drive. Google Drive as well is a type of cloud available for Google users, right? So in Google Cloud, you can put in your files, your information, right? So these are interesting ways of accessing and using cloud. You also have the private cloud. The private cloud is used by organizations, right? But now most organizations even use hybrid cloud because it's cheaper and allows them to scale. They use hybrid because they have some sensitive information that they would not want to have in the cloud. So those kind of sensitive information, they have them on their own computers on premise, right? So this is just the understanding of what cloud technology is about in the general. The opposite of cloud computing, like I said, remember I said think of cloud as being remote. So the opposite of remote would be on-site. So your data is either on-site or is somewhere in the cloud. So most secondary data, you find them in the cloud because you are not the originator of that data, right? So think of cloud as remote. Okay, so cloud is not available to data alone. You can have cloud computing services in form of infrastructures, right? People even use or access computer machines as though they were in the cloud. It's available even for servers, for network operating systems, right? And the interesting thing of cloud is most time on a pay-as-you-go basis. And you also have cloud business as platform as a service. So these platforms could be platforms for software development application, or it could even be platforms for domain news, even medical platforms, right? Various different kind of platforms, can access as a cloud service, or you can even make available in an organization as a cloud service to your staff. Then you have serverless computing cloud service type. This helps in handling setup, capacity planning, server management for you, right? Then you have software too as a service. So these are various types of resources and facilities you can have in the cloud, and those are part of the things that makes up cloud technology. So I've talked about this in my conversation, and in order of popularity, we have AWS Cloud, which is called the Amazon Web Services. And sometimes you have people who are specifically into cloud business or into cloud as a career. Like you have cloud engineers, right? So they are engineers that help managing cloud resources, right? Because there are also tools for managing those resources. So you see that the world of data analytics is kind of encompassing of various areas. You need to, like one of my mentors will say that you need to have knowledge of many things, but then you also need to concentrate on one thing. So having good knowledge of these various things, yeah, helps in helping you to come up with better quality outcomes or services. So that's the essence of all these various knowledge nuggets that we need to talk about. And it's a long session class. We have about 16 classes. So it's always good that we touch on this background basis and make clear understanding of them, try and have the clear understanding of all those nitty-gritties, and those understanding will help you really in your various endeavors. So these are the IT giants, and there are some other ones as well that are coming up gradually. You have the Alibaba Cloud, you have Oracle, IBM, Tencent Cloud as well. So these are various cloud enterprises. Great. So having talked about cloud, as data analytics, remember we said data can be in the cloud, and that's quite popular. You have far much more data in the cloud than you have on premise, because it's easier to access data that's been gathered by other people from the field or from their subjects and use them than for you to create data of your own. So you need to be able to access data from the cloud. Now, the process of accessing data from the cloud is usually called scraping. So just like you're using a rake to get quality chunks of data in the cloud. So that's just a concept or a theme or whatever that is coined for such. So it's called web scraping. So when people say, "Oh, I want to do some data scraping or web scraping," they are simply trying to get data from the cloud. So the extraction of data from the cloud is also usually done by certain software algorithms, which we call bots. So these bots could come in form of a something you need to install as a plugin, or sometimes it comes in forms of API. There has to be something interfacing between your own computer and where the data location is. So that integration software between your own computer and where the remote data is what we call as bots. So generally as bots, right? So sometimes, depending on the kind of interface, it could also be called API, application programming interface. Banks use that a lot when they want to do interbank communication, or maybe communication with some form of secondary data, sitting with some regulatory bodies or things like that. For instance, if you're doing a name check, or if you're doing a name check or a bank check on your app, right, that information needs to be checked with the destination bank, and there has to be some kind of interface between the data of bank A, which is your own bank, and the data in bank B, which is their own data. So like a standardized form of communicating between them is where computing knowledge comes in, and these are algorithm softwares that we've been talking about. So for data scraping as well, you are going to need some form of bots, right? So then you also need to understand that your data can come in different forms, and these are usual file formats for accessing your script data. It could come as a CSV file format. It could come as a TXT, text file format. It could also come as Excel file format. Then more popular ones for data in the web are the XML and JSON file format. The SQL file format is usually for data that is scraped from some specific databases. They also come as SQL file format. So whenever you see a file that is .this or .any of these extensions, then you know that it's containing data. It's containing something that you can access. So these kind of files they are different from your word processing or text-based files, right? So this type of files can contain data for you to gain insights about, and they as well can contain several rows of data, right? Even CSV can contain as much more data than Excel, right? It's just that it does not come in the table-friendly form that Excel file format will come, but it's very common. You find them commonly for your data processing files. So just be aware of these various data processing types. So then, okay, that's great. That's the end of our first lecture. We're going to perform this demo. But before we do this demo, I'd like to do the next lecture quickly so that we can concentrate on the demo, on all the demo. So in the first demo, we are going to be scraping data from Peter. Then in the next demo, for the second training, we are going to be visualizing the data we have scraped. So while I'm doing the second training, the second teaching, I would like you to check on your Twitter account, and if you don't have one, try to open a Twitter account. It will not take time to have it open. So thank you for listening to the lecture. See you in the next lecture.